Okay, welcome once again to Teams Top Notch Academy. So today we're looking at this question, which is if a pump is capable of lifting 500 kilograms of water through a vertical height of 60 meters in 15 minutes, the power of the pump is, these are the options that are given. So when you're given a question of this kind, so all you do is to list out the parameters, then you continue with your solving, which is we'll now write our solution. So we're given that a pump is capable of lifting 500 kilograms of water. This kilogram indicates the mass of what is being lifted, which is water. So while the mass, we're given that the mass of the water is what? 500 kilogram. So the next thing from there is the height of what? A height in which this mass of water, this particular load is being lifted, which is given to be the distance, or you say the height is what? 60 meter. Then after that, this lifting of a load took some time before it was lifted. So the time it took this load to be lifted is what? 15 minutes, which will now, we are given what? That this is what? 15 what? Minutes. So the next thing there, they say that we should find the power of the pump. The power of the pump is what we don't know. So after listing the parameters like this, the next thing you do is to represent this in a diagrammatical form in order for you to understand it better. You understand? So, but in case you're in examination hall, it's not really necessary, maybe in times of jam, but if it's internal exam, it's very, very, very important so that the person looking at the work will know, yes, that you know what you did. So in this case now, we say that the pump, let's assume this to be a pump. Okay, let me present this with this. Let's assume this to be a pump. So right here, this is our pump. So this pump is lifting a bag of what? Pure water. Let's say this bag of pure water is somewhere here. Let's say this is the bag of pure water to be lifted, which is 500 kilogram of pure water. This is the bag of pure water that is being lifted, and they say that it's lifting it through a height, a vertical height. There should be a height. Let's say we're using a string, something of this kind. This is what is being used to lift this particular load, which is a bag of pure water. I'll call it bag of pure water. Bag of what? Water. This is bag of water. So remember, when this bag of water was being lifted, it was lifted through a height of what? It was lifted through a height of 60 meter. According to them, they say that 60 meter is the height that it took this to be lifted. So after that, as this load was being lifted, there was time spent for it to reach up to this point where the pump is being located. So the time it took can be written here, which is said to be what? 15 minutes. It took it 15 minutes to lift this particular load. This is the diagrammatical form of the statement here. So if you are able to represent this in its diagrammatical form, it means you understand what they say you should do there. So let's go ahead to solve the question now. So first thing you need to do again is to recall that power is equals to a work done per time. The work done per time is what is given as power. So our power here now, power is equals to work done per what? Time. So initially from our previous class, I stated the formula for work done, and this the formula for power as well. So this is the formula you use to solve this particular question. But remember, our time here is given in minutes. So you need to convert this time to seconds. But even if you don't want to convert it to seconds, it's still okay. But it's advisable that you convert it to seconds first before you continue solving. Why? Is because our answer here is in seconds, because if you look at the answer, it's supposed to be joule per minute, but it's now joule per seconds, which represent the unit of power, either joule per seconds or we call it watt. But here they represent it in joule per seconds. So that is the reason why you should convert this to what seconds. But even if you don't want to convert, you can still solve with minutes. Maybe at the end of everything, then you convert to seconds for you to align with the answers or the options that are being given to you. So, but in this case now, I'm going to convert mine to seconds first before I continue solving. So, remember, we are given work done per time as the formula for power, but we don't know what is work done. We can recall also that work done is equals to what? Force times what? Force times what? The distance. The force being applied, and you know why the load was being lifted. It was lifted due to application of force on the load. So that is why you say force multiplied by what? Distance. Because as the force was applied to lift a bag of water, the bag of water was lifted through a distance, and that is what that will give us the work that was done on it. So that is now we were given this formula: force multiplied by what? The distance, where S represents the distance, and the distance was given from here to be 60 meters. Sorry. So the force is not given from the equation, but we can also recall that force. Can also recall that force is equals to mass times what? Acceleration. One may ask me, how do we get our acceleration here? This acceleration is called acceleration due to gravity, and it's not given from the equation, so it may not be given. But you also need to know that the force, the mass, the acceleration due to gravity is given as a 10 meter per second squared. This is a constant that is being used in terms of solving equation of this kind. So it may not necessarily be given, but you should know or recall that this formula exists, or this constant exists. Why? Is because the load, according to the question here, that the load, the pump was lifting the load, which is the bag of pure water or bag of water from the ground. As it was lifting it, you know, the force of gravity acts from the top to down. So as it was lifting it, there was a force of gravity acting it, pulling it down. So for it to overcome the force of the gravity, that is how it got to the top. It was able to lift it. So this force of gravity that was pulling it down will also be considered in terms of solving a equation of this kind. So, and this force of gravity is given to be 10 meters per second. So that's why we're using this 10 meters per second in our solving. So if you recall that force is equals to mass times acceleration, we are given our mass here to be 500 kilogram, and then our force here can now give us mass being 500 kilogram multiplied by what? The acceleration due to gravity, which we got here to be what? 10 meters per second squared, which is a constant. So if you look at this now, you see that our force is 5,000 Newton, because the formula for force, or the unit used for measuring force, is Newton. So that's why we are getting our force to be 5,000 Newton. So remember that we are given our distance here. Our distance was given to be 60 meters. So, and we know that work done represented with capital W is given as force times what? distance, and we got our force to be 5,000 Newton, which implies now that this is 5,000 Newton multiplied by the distance, which is what? 60 minutes. So in this case, 60 meters, sorry. In this case now, we are given this. So we can say 6 times 5 is 30. Is 30. So this can give us this 30,000. Okay, let's confirm this. We have 5,000 multiplied by what? 60. So 0 will still go here. So if we do this, we have 1, 2, 3, 4. Then multiply by this, we have another 30. So it means it's giving us 300,000. 300,000 watts joule as the value for the work done. So after we've gotten your work done now, so we can now go back to the formula, which states power equals to that our power equals work done per what? Time. Remember, I told you initially when we started that the time here is given to be in minutes, and we have to convert our time to seconds based on the options that are given here. So if we do that now, we know that our time is given to be our time here is given to be what? 15 minutes. 15 what? Minutes. And if you convert 15 minutes to seconds, we are going to multiply this by what? 60 seconds, which will give us 15 multiplied by what? 60. So how do we do this? We can take this to be 150 multiplied by 6. 6 times this is 0. Then 6 times 5 is 3. Is 0. Then carry 3. 6 times this is what? 6 plus this is 9. So we're going to have 900 what? Seconds. So that's the value for our time when converted to seconds. So this is what we got now as the time. So to get our power now, it's not hard because we already know what the work done is and also what the time is. So if you substitute the values of the above, so you will be getting something like this, that the power expanded or power to the pump to leave the load is work done, which is 300,000 joule, 300,000 joules, sorry, all divided by the time, which will go to be what? 900 seconds. This is in joule, this is in what? Seconds. And now you know it aligns with the options that are given here. So we can cancel this. This can go against this. And if we are to divide this here, we can say 3 here, we get 3. 3 here, we get 1. So that means we are having that our power here now. Okay. So that means we are having that our power is giving us 1,000, because we have cancelled this and this is already giving us 1. That is 1,000 remaining here, all over what? 3. So how do we go about this now for us to know whether if we get an answer from the option, the correct answer? So 1,000 divided by 3, you can punch your calculator, then you get the correct answer. But for me, I will go by this, that power now is equals to how many 300 is in 1,000. So that means we're having 3. Okay, we're having 3. So that means we're having 3. Then when that is 3, okay, that is 900. 3 times, that is we're having 300. Okay, then remaining 100. So under 100 we're having 90. 90 divided by 3, we're having 30. So we're having here 330. Then remember, from 90, we're having 10 remaining. So 10 will go with 9. 3 into 9 will have what? 3. So this is what we're going to have. as our answer. So we're having that the power expanded, or the power of the power of the pump is what? 333 what? Joule per what? Seconds. This can also be represented as our power being this, representing it in this form. We will have 3 multiplied by 3 times 10 raised power what? 2 joule per what? Seconds. This is our what? Answer. Let's check the option and know if we got an answer that is okay. We can choose from the option here that our answer here is what? Option C. Please do not make mistake when solving a question like this. Option C is the what? Answer of this particular a jump question. This is a jump question. So now let me give you what to do. You can solve this using another formula of power. We know that power is another formula of power is given to be what? Force times what? Velocity. So this is an assignment for you now. Go and solve this particular question using this formula, which is force times velocity. I know whether if you arrive at the same answer, which is this answer of option C that we got. So let me just show you let me just show you how this formula came about, so you also know what to do, maybe how to apply. Recall that that power is equals to what? Work done the what? Time. And work done is given as force times what? Distance all over what? Our what? Time that is here. So if you do this like this, so you know that velocity is the distance moved per what? Time taken. So that means here now this is our power now is giving us what? Force multiplied by what? So distance over time is what? Velocity. And that's how we got this formula. So apply this formula in solving this question and know whether if you're going to get the same answer that we got. If you get the same answer, then drop it in the comment section so that I will go through it and see whether if you got the same answer. But if you got a different answer, also drop it there. Thank you very much. Please do not forget to subscribe to my channel. Always hit the notification button when you subscribe so you get new videos of this kind. And if you are watching from Facebook, please try to like, comment, and also share this video. And also do not forget to follow the Facebook page for more videos of this type. Thank you very much.